Hi everyone. Today, Muhammad Izzuddin bin Tajuddin, will present about application of second order differential equation with others my colleague, which are Nashita Mutiara Gandana, Salma Yasir Sadiq Hassan, Siti Najiha binti Sulaiman, and Siti Noizati binti Sanusi. So next, this is a table of contents, which is for one, interaction types of secondary order ordinary differential equation. For two, problem statement, description about the problem that are going to be solved. For the three, result and discussion, the solution of the problem. And lastly, conclusion, the conclusion of this assignment. Next. First of all, we go to the introduction. Okay. Secondary order ordinary differential equation. For the general equation, we got that a y double prime plus b y prime plus c y equal to fx. So the solution will be yx equal to yhx plus ypx. So the homogeneous equation solution, we must find the roots using the characteristic equation, which is am square plus bm plus c equal to 0. For the lastly, non-homogeneous equation. Undetermined coefficient method, for the first one, we have 4 cases. For the case 1, polynomial of degree n. For the second one, form of c e to power of mx. For the third is sine or cosine function. And the lastly, case 4, sums or products of case 1, 2, and 3. And the other method, which is for the number 2 method, which is a method of variation of parameters. It is used to determine a particular solution, and it can be applied to any case, including the 4 cases. So next, I will pass on to Salma Yasir Sadiq Hassan to continue the presentation.
I'll present about the problem statement. Our problem statement is an RLC series circuit, which is a simple electric circuit that consists of resistance is 2/5 ohm, inductance of 1/5 Henry, and capacitance of half, and electromotive force is given as 50 volt. In our problem, we need to find the charge on the capacitor by assuming onto two initial conditions when the capacitor is 0 and the initial current is 4 ampere, and that's shown in the figure. Secondly is the results and discussion part. Based on the information given before, we will analyze it into two conditions: when time is equal 0 and the charge is 0. The second condition, when time is 0 and the current is 4 ampere. We will be able to determine the constant value in the equation A and B. And by that, we will be able to find the charge on the capacitor QT. The equation for RLC circuit is given below by doing the sum of all the electromotive force on the circuit. First is L with the differentiation di/dt, and that's the electromotive force for the inductance. Second is the resistance multiplied by current, and that's the electromotive force for the resistance. And third is the electromotive force for the capacitance, Q/C. By summing these three terms, we'll get the electromotive force, ET. And as mentioned before, based on the initial conditions, Q0 and I0, where the I equal to 2/dt. Then in our RLC circuit, we know before that current is equal to dQ/dt. And if we differentiating both sides with respect to it, it will become a second derivative. By substituting in the previous equation, we will be able to get the second derivative differential equation for the RLC circuit. We will substitute all the data given inside the second derived equation, and then we divide it by 0.2 to get a coefficient of 1 beside the second derived, which is d squared q over dt squared. We can see that this equation is a non-homogeneous equation because it doesn't equal to 0 and shows an fx of 250. And also it is a method of undetermined coefficient because it's a polynomial equation. Next, we start solving by finding the value of QH, which is Q homogeneous, m squared plus 2m plus 10 equal to 0. That's our quadratic equation, where a is equal to 1, b equal to 2, and c is equal to 10. Then we determine the root of the equation by using b squared minus 4ac, which is less than 0 and shows it's going to be a complex number. We'll solve it using quadratic formula, where alpha is equal to -1 and beta is equal to 3. Usually the equation in this case for the homogeneous will be e to the power of alpha t, a cosine beta t plus b sine beta t. And we will substitute the value of alpha and beta inside that equation to make it e to the power of -t, bracket a cosine 3t plus b sine 3t. Then we will find the value of QP, which is based on fx 250, and the QP will equal to XRC. We will substitute the value of R equals 0. We will get the equation QP equal to C constant, and we need to check that it doesn't equal QH value, the QP. Then we will substitute the first derived, second, and the QP value inside the main equation. We will get that QP second derivative is 0 plus 2 multiplied by 0 plus 10c equal to 250. Then 10c equal to 50 will give c equal to 25. So QPT equal to 25. And then we can find the non-homogeneous equation by adding the homogeneous QH plus QP. And we can get the final solution will be E negative t, A cos 3t plus B sine 3t, and we plus the QP, which is 25. Then we will work out to find the constant A and B using the two conditions mentioned before.
All right, so from the previous slide, we can then substitute the initial value problem data from the question into QT equation to get the value for A and B. For the first case, when t is 0 and q equal to 0 coulomb. So we substitute t equal to 0 into the equation, e to the power of 0, open bracket, a cos 0 plus b sine 0 plus 25 equal to 0. And we have calculated this, which will result in this equation, a plus 25 equal to 0. Then we will get a minus equals to negative 25. So we can then substitute the value of a into the qt equation, which we will get qt equal to e to the power of negative t, open bracket, negative 25 cos 3t plus b sine 3t, close bracket, plus 25. Next, for the second case, where the value of current is 4 ampere, as I equal to dq over dt, equation 3 need to be differentiated so that the initial value of I can be substituted into the equation. So we differentiate the value of the equation dq over dt into this, negative e to the power of negative t times negative 25 cos 3t plus b sine 3t plus e to the power of negative t times 25 times 3 sine 3t plus 3b cos 3t. Next, we calculate, expand the value of negative e to the power of negative t, and we will get this. And finally, we will get e to the power of negative t cos 3t, another elbow bracket 25 plus 3b plus sine 3t, elbow bracket negative b plus 75. So as I equal to dq over dt equal to 4, we substitute this value into dq over dt and t to equal 0 in the previous equation. So we'll get this 4 equal to e to the power of 0 times cos 0, open bracket 25 plus 3b, plus sine 0, open bracket minus b plus 75. And then we'll get 4 equals to 25 plus 3b. And finally, we calculate this and we'll get b equals to negative 7. Then we substitute b's value into equation 3 to get the final answer. Therefore, we'll get the final answer, which is Qt equals to e to the power of negative t times negative 25 cos 3t minus 7 sine 3t plus 25. So in order to verify the value of the chars given in the equation, we'll utilize the digital software National Instrument Multisim on the 14th edition that can be observed as below. So we put in the value of the voltage of the source, which is 50. And for the hertz, we just use the normal given one by Multisim, which is 60 hertz, and 0 phase angle. And then we'll insert the value of each unit for the resistance, 2/5 ohms, for the inductance, 1/5 Henry, and for the capacitance is 1 microfarad. And not to forget, for the circuit to work, we have to put in a ground. So in order to get this graph, we use DC transfer characteristic to determine the value of to determine the consistency in the chars. And this is the AC sweep that we use in order to validate the value of the capacitance here, the blue one, which is constantly raising to prove that the answer is justified. All right, for the conclusion, I will pass it on to my colleague, Muhammad Izzuddin.
Okay, for the last is a conclusion. Okay, the would be the equation of RLC circuit is L di over dt plus Ri plus Q over C equal to electromagnetic force, which is Et, where I equal to dq over dt. There are two ways to solve the equation. First, we must change the equation into a homogeneous equation or solve the non-homogeneous equation. Okay, for the first option, it can be used if the equation asks for a solution in the IT form, which is the current in the circuit. However, if the equation asks for a solution in the QT form, which is the charge on the capacitor, it is better to use the second option. And for that, uh, for the lastly is for the references that we use here. And for that, we end our presentation. Okay then.